Hi, everyone. Thank you so much for coming today. My name is Arisa, and I'm the co-founder and CEO of Cega Finance, which is a DeFi protocol on Ethereum and Solana. Obviously, when we went multi-chain, there was a lot of struggles that we went with. And so I started looking into interoperability space and got to know Peter and the team. Super excited to be moderating this panel today. So maybe just to kickstart things off, if everyone can quickly introduce themselves, your name, what you do, and then also a little bit about what you work on. So Jacob, if you want to start.
Yeah, so Jacob, I'm head of strategy at Celestia Labs, basically working on building out like the early Celestia ecosystem and working with teams like Astria and Saga to sort of make sure that we have the whole stack sort of in place, and lots of different options for folks who want to experiment with the first like modular blockchain network, basically.
Yeah, Josh, I'm the CEO and co-founder of Astria. We're building the shared sequencer network. Previously worked at Celestia. It's kind of the goal of making it easier for rollups to be decentralized by default, so that they can kind of inherit decentralization as a service from an existing network.
Hello. Cool. My name is Jin. I'm one of the co-founders at Saga. We're a project that helps a developer get sovereign chains on a kind of like a one-click solution. And so the idea is to make the developer journey a lot easier to get their own block space. And sequencers is something that we've been kind of exploring and thinking a lot about in relation to some of these other projects up here. So.
Awesome. Thank you so much for the intros. I'm especially interested in learning more about sequencers and decentralized sequencers because Cega is a DeFi protocol. We do options trades on chain. And when we source liquidity on chain for these options, sequencers are really important because it helps prevent market makers from front running the positions. It helps us settle faster. And for exotic options, for instance, these settlements happen not just once at expiry, but it could happen multiple times over the course of a trade. And so it's really important to understand how sequencers work in order to make sure that everything settles at a good price for our users. So, we obviously care about this a lot. What other projects out there do you think, get affected a lot by sequencers, and which projects do you think are ahead of the curve right now? Maybe we can start from Jacob.
Yeah, I think I'd actually say something maybe counterintuitive, and that I actually think like centralized sequencing is actually underrated for a lot of things people want to use rollups for right now. So there's a lot of for example, folks like who are building on-chain games, things like that. It's actually like a feature for them because they're not as there's really not as much MEV necessarily to capture. I think they're really more interested in just like performance, and like you can still have some amount of self-confirmation with centralized sequencing, et cetera. So right now I see a lot of the early adopters of rollups pretty much across the board are just using centralized sequencing. Look at like the majority of TVL in DeFi that's not on Ethereum mainnet is on Optimism and Arbitrum, right? And a lot of obviously there's still MEV and stuff, but like basically there's basically like a lot of also like for those teams like they're getting massive like inflows of ETH from fees and things like that, and so it's like there's really their incentive to decentralize it is actually. Obviously they have a clear incentives to do so, but they also have reasons like not to do so, right? And so and there's teams that that's why they're picking rollups in the first place. On the decentralized side, though, it's basically to me it's basically just all the same things that we're used to seeing people build. Mostly like most of the things that people are going to use Cosmos DK and app chains for. And what's nice about it is that like sort of there's a whole new sort of space around or sort of design space around like how you basically like basically how, you can have faster latency potentially, lower latency potentially. You can have, because you don't necessarily need communication overhead for like having multiple validators sign over every block. But then there's also, various like MEV and or like restaking designs that people are excited about. Like Espresso is obviously doing that. And then you also have sort of like folks who are very excited about kind of like the idea of like a base rollup, where basically you inherit, you basically use the L1 basically for sequencing. Execution still happens on the rollup, but basically and basically leak MEV to the base layer. And so for stuff again that doesn't have a lot of MEV, that's like, but maybe you want it to be decentralized. So if Nouns DAO on Ethereum wanted to launch a rollup, like they probably, a base rollup would make a lot of sense for them. They're not latency like sensitive, but they want to be like Ethereum aligned, and but they don't really care about like MEV really at all. So I think that's kind of like how I think about the set of like opportunities.
Yeah, I guess it might be useful to define, like when we say sequencer, I think what we're really speaking about is like the block producing node for a rollup. It's like the general kind of like terminology we're using, which would be the equivalent of like a validator node on like an L1 rollup or a sovereign Cosmos chain. And what we're seeing there is like, it's not strictly necessary to have a sequencer for a rollup. The reason we see there being sequencer for rollups is fundamentally because of like a user experience improvement. Like users like having faster block times. And if you rely on like a base rollup, to like Jacob's point, right, you're dependent on the block time of the L1 chain. And it just generally like kind of like constrains you to that block time, and a lot of the benefits that users would expect are not provided. Why we think kind of decentralizing the sequencer is very important is like what we see right now with like Optimism and Arbitrum running these fully centralized sequencing nodes, is that like it's kind of like the user is trusting them. There's a lot of discussion around MEV and how sequencers affect that, because fundamentally they are the node responsible for ordering, which means that they could inject front-running transactions, sandwiching transactions, or whatnot. And right now you're just making a trust assumption that like Optimism or Arbitrum does not have some kind of like back office like sock puppet accounts that are like front-running every transaction on their chains. And why we think decentralizing that is important is because that gives us to this incredibly neutral layer where we say, no, it's not just one party who's trusted, because we have like a robust financial ecosystem with like trusted intermediaries. Like that's just TradFi, right? To some degree, if we want to do DeFi, we want to remove these centralized points of kind of like trust in the system, and that's where we're seeing this kind of I guess it's like a single point of failure right now in the system of trust. So that's what we see as like necessary to decentralize.
So in Saga, we have a very different viewpoint of how rollups and sequencers will function in Web3. So when you think about decentralized sequencers, you essentially kind of come back to the paradigm of app chains. You're essentially just rebuilding what exists in proof of stake today with slightly different assumptions and behaviors that you like. And so the problems with app chains and proof of stake is that it's, the first step is you need to incentivize validators and find validators. And once you start decentralizing sequencers, you kind of run into the same issue. So why are we interested in sequencers on our side then? From our perspective, one of the biggest benefits that sequencers and rollups kind of bring to the table is that you no longer have to guarantee 66% of your kind of node operators to progress a block essentially and have a finality. And so with rollups and sequencers, you can kind of reduce that to 51% consensus, which means that generally you can make the system much cheaper. And so that's the reason why we're very interested in sequencers and rollups in general. But outside of that, I think like who's like rollups good for? I mean, it's the same answer as who wants app chains ultimately. It's the same market. It's a direct overlap in our opinion, and rollups is just a way to get that in a cheaper way ultimately.
Yeah, thank you. And I think Josh, you mentioned specifically about like decentralized sequencers being this neutral layer that allows for different purposes if different app chains. What specific design areas and opportunities do you think actually opens up with decentralized sequencers versus what was traditionally like there. Maybe you can start, and then Jin and Jacob, if you can add on, that'll be great.
Yeah, so it depends on like what our starting point is. If we start from like a monolithic blockchain and we say like, what is the argument for rollup? Like fundamentally, it's a scaling solution. It allows you to have a like faster kind of like off-chain execution of data that is then kind of like snapshotted or like batched to a layer below it, and it lets you rely on that layer below it. To like Jing's point, like as like this one of n honest majority assumption. Like that's the reason we use rollups. In the meantime, we kind of used centralized sequencers for this because users wanted a faster user experience and they just wanted those fast block times. But the trade-off there is now your liveness at that block time is now dependent on like a centralized entity, and it's not your safety that's dependent on it. Like your funds are still safe through like the one of n honest majority, but you fall back to that block production time. When we think about decentralizing those centralized sequencers, it's not necessarily that you're getting some inherent like benefit in that like the user experience does not necessarily improve. To Jacob's earlier point, like there's actually a risk of the user experience degrading when you use something that is decentralized. There is something kind of inherent of like decentralization has trade-offs. The argument is that just it is inherently kind of like it's the point of doing kind of like this decentralized finance blockchain stuff. If we want to have centralized points of failure, well, like, many players run like central limit order books in like the TradFi scene. You can go use that if you are comfortable having like a trusted intermediary. The goal of decentralization is, as you know, to move to this neutral party that is not the only entity responsible for ordering, and it creates a market where you have to say, okay, there's a market of multiple actors trying to provide the best service for doing block production for multiple users.
I think I agree with that, but I think there's one part of the ease of use that single sequencers kind of fail, which is finality time, which kind of corresponds to bridge time, essentially. So when you have a single sequencer, you need that time period that essentially extends the finality time by the time period that you need those to kind of verify or check whether or not there's problems, essentially. And so you delay IBC or other kinds of bridge communication channels and finality in that by that period of time, which ultimately kind of affects the user experience as well. And so I think when you think about it in terms of an application like individually, yeah, I think you're right. There's as you decentralize further, usually the user experience kind of degrades. But I think there are actually certain scenarios where it's kind of the inverse, where when you have one, the user experience is pretty terrible. And as you get more and more decentralized, these bridges become easier to use because you can kind of guarantee that finality of the bridge transactions ultimately. So that's something that I just wanted to add.
I guess it's worth knowing there's a little bit of nuance in that point. So this is around like optimistic bridges between like rollups right now. And fundamentally, like a receiving side bridge is like a subjective kind of like social consensus of like what is an acceptable kind of like settlement mechanism. And we've generally assumed like one party just saying, hey, this is valid is not acceptable. But we will say, okay, one party will post this, and then after 7 days, if no one else has challenged that, then we will say that is acceptable. And that's fundamentally what an optimistic bridge is. If we move to these decentralized sequencers, we can go towards this, we're at IBC Summit, right? This IBC style bridge where you say we have a consensus over this state root, and we can accept that with faster finality than saying, well, we're relying on one trusted party, so we want to have a window where we can kind of double check their work.
Yeah, and that's kind of where the benefits, I think, of this architecture makes a lot of sense, because in an app chain, you always necessarily need 66% to prevent double sign attacks, because as soon as somebody has 33%, you can kind of start having these kinds of malicious activities happening, whereas with a DA layer and with rollups, you can kind of cut that down to 50%, which means that you're saving a lot of kind of infrastructure costs, actually, even though you're getting the same amount of decentralization. And so that's what kind of Saga, we've been kind of obsessively thinking about, and our CTO and our technology team has been really focused on trying to make this more accessible, considering also like our system is based on trying to launch millions of potential app chains in the future. And so by cutting from 66% to 50% for every single one of them adds up to a significant amount of kind of cost savings on our end. So that's kind of how we've been approaching this space.
Yes, I was gonna say also one other thing is my understanding is also like there's people who are looking also like the fact that you don't really need like bonding periods, really like meaningful bonding periods for the sequencer as well. So even if it's decentralized, like there would be like obviously you're allocating them based on stake, but you don't have the same like you're using like a DA layer or something for security ultimately, and so you're not actually you don't need you have. Sorry. Oh yeah, you're using a DA layer or something for a DA layer for security. You ultimately don't need to rely on things like bonding periods and stuff to defend against like the classic, like proof of stake, like challenges, right? So, or vulnerabilities, right, in a naive design. So I think like there's a lot of folks who are sort of thinking of it also like how do you also do like use like restaking and things like this. Like on the eigenlayer side, it's like a big part of their like a lot of folks that building there like thinking about that. I'd say like that's still like completely nascent. We don't really know, like for example, like what happens when like people start restaking, ETH in particular. It's like well, you basically take the same validator set that you have on Ethereum, and now like it's like an even bigger. Like you basically have like you're bribing this. You can basically bribe people the whole way down, right? And so there's sort of like people I think a lot about like how do you make that incentive compatible. I don't think that's like really been figured out or sorted out. I don't know if you've thought about that yet, but yeah, I think like there's a lot of these like missing these gaps sort of remain in this whole part of the stack, and like I think it's like shared sequencer is very popular right now, but there's also just clearly people who would love to just redo the Cosmos like app chain sort of like design with just like a decentralized sequencer set, and that's like really what they're looking for at the end of the day.
Awesome, thank you. So I think moving from like a single sequencer or like a existing sequencer to decentralized sequencer probably requires a level of steps in order to get there. So maybe starting from Jin, like what do you think is like the most sustainable path into decentralizing a sequencer?
So philosophically, maybe the people will disagree with kind of my take on this, but philosophically, I think a decentralized sequencer network will just essentially rebuild what we have in proof of stake. And once that happens, essentially what you're doing with sequencers and rollups is that you are decoupling the consensus part from the finality part ultimately. And because of that, I think what decentralized sequencers will eventually find out is that the best way to enforce a sequencer's behavior is stake, is having something slashable, which means that you're just rebuilding kind of some parts of proof of stake to allow these sequencers to have something that's valuable and in protocol being able to be slashed essentially. And so that's at least so from our perspective though, I keep coming back to this, is the way that we built this out is we already have a proof of stake network with Saga. And we're extending essentially and taking kind of a lot of the benefits of roll-up and sequencers and merging that with a lot of nice behaviors with a proof of stake system. And so from our perspective, each of our validators will now become sequencers, and we just have to collect essentially the attestations from each of the sequencers to get to a quicker finality. And so that's our strategy, at least, of how we're thinking about decentralizing sequencers. There's a lot of other ways, by and large, there's a huge group of people who are thinking about this in terms of ZK, and then there's a huge group of people who are thinking about it in terms of optimistic rollups and how that goes forward. We're in the camp of how do we make optimistic and POS merge together into a solution that makes a little bit more sense. But I think there are other arguments out there. So.
Yeah, I guess we're entering at like the original question of like, what does it take to decentralize a sequencer? There's just kind of like, it's going to be very specific to like the given, we'll say like rollup or whatever, right? If we're talking from like an Optimism or an Arbitrum or like a ZK sync or whatever, and they need to like migrate that. I think Optimism is the one who's laid out like a pretty clear roadmap for like what they view as necessary to decentralize. This involves the smart contract, having additional governance on the smart contract. And to Jing's point, fundamentally, like, it is like a proof of stake network. Like, once you decentralize a thing, you have multiple actors. If those actors are not chosen by like a trusted committee, which would be like a proof of authority network, then you have to have some mechanism by which you do a leader rotation. That is probably going to be proof of stake. People aren't going to like accept like a new proof of work chain. So it's going to be proof of stake. You allocate that somehow. You have these kind of, untrusted parties, and you just have to have a proof of stake network that guarantees you have some means of like verifying them and slashing them in the case of like bad behavior. And fundamentally, what we're building like at Astria as like a shared sequencer network is just like an app chain, right? It is like a new network that has a proof of stake kind of committee, does leader rotation among that, but it is specifically accomplishing the task of doing sequencing for multiple different rollups.
Awesome. And I think we're starting to head into our very last question of the day. So, obviously we're here, it's the IBC Summit. Maybe if you can answer the last question on why you think Cosmos SDK sequencers are actually better or worse than others, and what is something that you think they do really well on, or something that they can improve on. Jacob, if you can start.
Yeah, I don't know. I don't know if it's like Cosmos DK per se that has much to do with that. I think it's. I mean that's kind of like what RollKit or even like Astria are using for, at least for the Tendermint part. Sorry, that's what you're using for the Tendermint part of the actual shared sequencing chain. But ultimately there's a lot of people designing these things that have nothing to do. That and particularly the ones in the ETH world. I mean they don't really need that. They don't really need Cosmos DK at all. I mean they're just using like restake, like in the case of the espressos and whatnot of the world that are Optimism Superchain, like none of them are really like thinking about that much. But what's nice is that you have this battle tested like proof of stake, infrastructure, right? That or a consensus infrastructure from Cosmos that can just kind of be repurposed for these purposes in the short term. That's kind of like what's happening with with like folks like Astria and others. But I think like in the sort of like in the long term, we're just seeing, we're going to see like a really big, I think like more innovation in like a lot of effort put into like new, sort of like basically dedicated sequencing like algorithms as opposed to just like repurposing like Tendermint. And there's like a lot of people I know. There's like the Typhon, like also the efforts with like Typhon and stuff like that. These other improvements that kind of think about cross-chain composability and stuff from day one. But otherwise, like it's sort of like for now, it seems like almost everyone aside from what's happening in ETH are basically just like want to use like something that's battle tested, et cetera. And it's kind of a one thing I'll say is like it's kind of funny because it's like an inverse of the normal set of affairs where Ethereum stuff is generally considered more battle tested, and in this case, like with like Tendermint versus like what Espresso's building or Eigenlayer or like Optimism stuff, like Tendermint is like way more battle tested than as an option than that. So it's kind of like it kind of makes sense that would be what people would be choosing, right?
Yeah, from our view, so like our proof of concept, like shared sequencer chain, like is like a Tendermint plus Cosmos SDK chain. From our view, like Cosmos K isn't like the necessary like more important aspect of that, but like fundamentally as a proof of stake network, we view Tendermint as this very, very robust battle tested like PBFT network. It's like formally verified, right? It's run billions of dollars through it. Like there's been like one incident, but like there was no like leakage through that incident, right? So we're like you can trust that, and it's not 2018 where everyone's trying to differentiate on saying, oh, we're going to have like a better consensus algorithm, and that's going to be our core differentiator. We're saying, look, we need a proof of stake network. We need to kind of meet these security characteristics that we have to provide these kind of like fast, soft commitments as a sequencer. And Tendermint is like more than good enough. It is like the standard implementation. It's easy to work with. Cosmos SDK is obviously the most tested kind of integration with that. There's other alternatives. ABCI, ABCI++ are like flexible interfaces to work with Tendermint. But like Cosmos SDK is very easy to get a chain kind of off the ground that uses Tendermint and provides this. And we think it's kind of obviously the best starting point for building one of these kind of decentralized sequencers, and that's why we started there.
Yeah, I think kind of similar sentiments about the battle tested, but I think more so than battle tested is as a team, we're building out a product that people want to use, and so our engineers are day-to-day looking at kind of the technologies that are available out there. And the fact that the Cosmos kind of stack in general, specifically IBC and all the other, kind of consensus Tendermint as mentioned, there's lots and lots of teams that are quite passionate about all of this. Looking at and extending kind of features onto it means that we can take a lot of these features that other teams have built out and incorporate them into our kind of platform and system much easier. From our perspective, we're not Cosmos maxis by any means, but it is the easiest and kind of simplest way for us to build our platform at this moment, especially with the vision of kind of using IBC as a layer to coordinate all of these millions of chains that we want to launch. And so really the only option right now out there is Cosmos and Tendermint. Eventually, I think Cosmos and Tendermint will start evolving into something that is probably not what it looks like today, in my opinion. A lot of it is kind of diverging as well. So like Say, for example, is starting to look into different kinds of improvements, and every single Cosmos chain is able to now kind of leverage a lot of those improvements. And I think that's one of the biggest things that we enjoy and take from working with this framework. So.
Yeah, absolutely. And thanks a lot. Oh, I think the mic is very back. Yeah, and I think the battle testing aspect is like very much not something that people talked about like a few years back, but the trust and security that comes from actually having usage is incredibly important. And this is one of the reasons why like we're also looking into this space quite a bit. So thanks a lot. I think just one last thing. Does anyone have any announcements or any upcoming launches about your protocol that you want to mention before we wrap up?
Yeah, so we're I think it's phase 4 now of our incentivized testnet, the block space raise, and we're targeting this summer to go live with Celestia. So, basically gonna basically see how this incentivized testnet like sort of plays out and incorporate any like bug fixes and stuff like that. But overall, like we're targeting that right now.
Yeah, so we're looking to have kind of like a private developer network. I don't want to overcommit for the engineers right now, but we're targeting something like kind of like end of next week and hoping to have kind of a lot more technical details about like how we're running our system, like how we've designed our system, how you can integrate with our system, again, by end of next week or the week following.
We have a testnet that we launched and is onboarding kind of what we call innovators, which are people building on Saga. Some interesting stats, at least, is there's like 56 or so kind of chains that have launched in Cosmos, and our engineers were trying to figure out a way to tax our system, so they launched 500 chains essentially within our system in about 53 minutes, and so that's a limit that's set by us, and so if we can put like 2,000 in there tomorrow, as long as we have kind of the infrastructure necessary to do that. So. Come join our innovator program and come test on our testnet.
Wow, that's super exciting. So many launches that are coming this summer, especially in this space. So really excited to see all the innovation. And for those of you that are working on this interoperability problem in this space, if you have any USDC sitting around, please try out Sega.fi for staking as well. Thank you everyone for joining us today. And yeah, please have a great rest of your day. Thank you very much.